All right, section 2.6 is similar to 2.5 in that we're going to be working with segments in angles and measurements. Now, where 2.5 was addition and subtraction properties, today we have the multiplication and division properties. And so this is when we're going to have segments and angles divided into equal pieces. For example, in our first example here, we have B, C, F, and G are trisection points. So remember, if they're trisection points, they divide this segment into 3 congruent pieces, right? We'll use 2 on this one just to make it distinct from the other one. Now, if they say AB is equal to EF, which is equal to 3, we know that those are 3. And in fact, we know all these pieces are 3 because it's trisected. And so we know that AD is equal to 9, and we know EH is equal to 9. And so if, in other words, if AB is congruent to EF, then we know that AD is congruent to EH because, as we can see, they do have equal measures. Here in the figure, it says KO and PS are angle bisectors. Well, if that's the case, then we know those are congruent, and we know those are congruent. It cuts the angle into 2 congruent angles. So it says if the measure of JKO is 25, if we know this is 25, then we know that's 25. And if NPS is 25, then we know that's 25. And we know that JKM is 50, and we know NPR is 50. And so in other words, if JKO is congruent to NPS, then we are going to get angle JKM is congruent to angle NPR. If the pieces of those angles are congruent, then we know that the big angles will also be congruent. So this leads us to the multiplication and division properties. So we can just say multiplication property. So in other words, if segments or angles are congruent, then they're like multiples are congruent. So this has to be bisected or trisected. So we have to have those elements to use the multiplication or division property. In other words, if the pieces are congruent, then the wholes are congruent. So this is when we go from small to big. So that was like our last example. If the angles are bisected, and if the small pieces are congruent, put congruent in there, then the big angles are congruent, or the big pieces are congruent. The division property is then their divisions are congruent. In other words, if the big angles are congruent, then the pieces or the small angles are congruent. And again, you have to, for both of these, they have to be bisected or trisected. So if, in other words, if you have 2 big angles that are congruent and they're bisected, you could talk about the pieces, the smaller angles being congruent then. So when you do these properties, when you use these properties, you have to look for midpoint, trisect, or bisect for the multiplication and division properties. It's breaking them into congruent pieces. And so remember, for the multiplication property, we need, it's going from small to big. And when we use the division property, we're going from big to small. We're dividing it up and talking about the small pieces congruent. In these following examples, they are from the section. You might use addition, subtraction, or multiplication, division. Okay, so we're kind of testing both. So let's see here. It says given DF is congruent to, so we have DF congruent to GJ. And notice it says midpoint. E is the midpoint of DF and H is the midpoint of GJ. So if we were doing this proof, we would have statements, reasons. We would have DF congruent to GJ. We would have E midpoint of DF, and we'd have H midpoint of GJ. Now, because we have that, we can go ahead and say DE, we can say what we want to say, is congruent to GH, and that is because we had the midpoint, we know it's going to break it into congruent segments. And so this would be division property. We would just say, oops, division property. So if the big segments are congruent and you know they're broken into equal pieces, then we can say the small pieces are congruent. Now, notice this is conclusion question mark. Okay, so this one's not a proof. We just got to fill in the conclusion. So for this one, if T and R, so if these big angles are congruent, and then we have these small pieces congruent, what can we conclude? Well, we can conclude that angle TNS, in other words, we can say these little small pieces are congruent, is congruent to angle TRS. And remember, this is not division property. This is from the last section, congruent angles minus congruent angles equal congruent angles. In other words, don't get these mixed up. The division property is when angles, it would be if those angles were being bisected or broken into congruent pieces. This is not that. This is what we learned in the last section. For this next one, it says given MK congruent to, so we got MK congruent to FG, and then notice here, KG bisects MJ and FH. So we have that keyword bisects. So if we were doing this proof, we would have MK congruent to FG, and then we have KG bisects MJ and FH. And so we can say, since we have that bisect, we can say that MJ, the whole thing now, is congruent to FH, the whole other segment. Oops, and because we were going from smaller pieces to big pieces, this is the multiplication property. Finally, we have, let's see, NOP. We have this congruent to RPO. So we have those two big ones congruent. PT bisects, again, keyword, NOP. And wait. Oh, bisects RPO, there we go. And OS bisects NOP. And then we have NSO complementary to angle 1. and RTP complementary to angle 3. Oh my goodness, this is a lot of given. So let's see. Statements, reasons. Angle NOP congruent to angle RPO. PT bisects angle RPO. OS bisects angle NOP. Angle NSO complementary to angle 1. Angle RTP complementary to angle 3. All right, this looks like it's going to be a good one. We've got like the new stuff. We got the old stuff with the complementaries. This looks amazing. Okay, so we have these angles 1 and 3 marked here. This is angle 1. This is angle 3. And ultimately, we want to talk about this NSO and RTP. So we probably need to say something about angles 1 and 3, because if we have angles 1 and 3 congruent, then we'll have complements of congruent angles are congruent and we're done. So looking at what we have here, we can say, since they bisect, we can go ahead and say angle 1 congruent to angle 3, and that would be the division property. Because in this case, we have the big angles congruent. They're bisected, so we know that the small angles are congruent. And now we can say angle NSO congruent to angle RTP, and that is because complements of congruent angles are congruent from the last section.